All right, so with that said, let's get started. So welcome again to the Analytics in a Day workshop. I'm very excited to show you how analytics can transform your business, and more importantly, show you some of the concepts that you might need to understand to be able to do more with the data, get a little bit more value out of your data, and also introduce you some newer technologies that Microsoft has made available in their analytics platform, specifically in Azure. And we're going to be talking about Azure Synapse, Power BI, and some of the integrations with other technologies that you may already be familiarized, such as Azure Data Factory, and some of the newer capabilities built in with Synapse, Data Factory, Power BI, etc. So with that said, let me introduce myself real quick. So my name is Jose Chinchilla. I'm the Director of Data and Analytics at Agile Thought for the US practice. And we do pretty much everything from data engineering to data modeling, data visualizations, infrastructure, as well as machine learning, data science. And I'm author or co-author of 3 different books, and I'm also hold several certifications. And I'm also a Microsoft certified trainer, and we do a lot of trainings as well. So if you're interested in a deeper dive, we can help with that as well. Also, I wanted to point out that last month we had our first Accelerate Summit, and the recordings are available on our website. And one of the sessions that I facilitated is the 3 must-knows when implementing artificial intelligence. That's a very great conversation if you're interested in machine learning, AI, and how to ensure that you're successful at implementing ML AI in your organization. Really great set of panelists from federal agency to healthcare, manufacturing, retail. A very good discussion. So I encourage you to watch them. Watch all the recording, but specifically the one I facilitated as a plug, because I think it was very interesting, very great insights. We got very great feedback from all attendees. At the same time, I wanted to just make you aware of all of our on-demand webinars, including similar webinars or workshops we've done like this one. But there's others like AI in a day or artificial intelligence in a day, some transformation agile type of workshops, webinars that we've done that have been recorded that are available for you on our website. So go to agilethought.com and you will see under the Insights menu the on-demand webinars. And then if you look at the About, you will see also the upcoming events and webinars that we have scheduled. So with that said, let me just give you a kind of a high level of our agenda, what we're going to cover today. In summary, we're going to try to cover the breadth of the cloud analytics capabilities from the Microsoft Azure platform perspective. I'll show you how to create an analytics pipeline that goes from data ingestion to traditional business intelligence, reporting, dashboarding with Power BI. How can you empower self-service and enable a truly data-driven culture in your business? So later in the workshop, I walk you through the hands-on training. So it's a hands-on workshop where you're going to have access to a lab environment that you will be able to follow along. And that will show you how to get started on your own in your cloud analytics journey. So we're going to talk about how to harness the power of analytics, how do the new experience of analytics looks like with Azure Synapse, and then I'm going to walk you through that hands-on workshop. So first, let's talk about the state of analytics today. So Microsoft believes that all businesses are data businesses, and so do we. At Agile Thought, we believe that although organizations have their business activities to drive revenue and profit for most for-profit organizations, or for non-profit organizations, government organizations, to ensure the that they meet the objectives, the goals of their mission. But regardless if it's a for-profit, not-for-profit, the underlying linchpin, right, of all business activities is data. And as you may already heard, data is the new gold, data is the new oil, data is the new currency. More and more, data has getting a lot more value, right? Because there's a lot of insights, a lot of predictions, a lot of patterns that you can see from your data. But however, data means vastly different things for different organizations. Although most leaders, as you will see in some of the surveys that we've been involved, most leaders understand the value of data, but they really don't know how to harness it, right? So it means different things, and we need to understand, what analytics can do for a business, how the cloud can enable better insights. What is the inherent tension in the traditional approach to analytics? And then what is the ideal state for analytics, right? What would be that future state or end state for analytics? So we'll talk through these ideas, through these topics, through the rest of the presentation today. And we're going to start with understanding, what data is. Hey, there's somebody that's okay. There you go, Naga. Thanks. So, so today, like I mentioned, data and analytics is at the heart of every modern business. And over the years, we had seen a big digital transformation happening across all industries, across all regions around the world. In 2020, for example, right, we've seen that a lot of organizations that perhaps had a digital transformation roadmap had to accelerate that implementation of become fully digital and truly digital. And due to all the different disruptions that we had, like the COVID-19, for example, right, has forced most, if not all, organizations to go mostly, if not 100% remote. Microsoft and some other big companies out there have decided to go fully virtual, and not require employees to come to work to a building, right? I think that may change over time, but I think during this period where everybody gets vaccinated, we get over the COVID pandemic, everybody is working from home, right? So that means that a lot of organizations have had to accelerate that digital transformation and adopt more cloud native technologies and solutions. So, so like I mentioned, at the heart of all these activities, and the whole purpose of all this digital transformation is to be more efficient and be able to access the data that's needed to collaborate and get insights from the data to be able to run businesses, right? So data is really what enables both the analytical power, which is analyzing past and gaining new insights, predicting the future, but be able to plan ahead and budget, right? Understand how this pandemic has affected revenue, how will the revenue and what will be the plan once things get back to normal, in double quotes. And what would that new normal look like, and how does that new normal impact the business? So, from the corner retail store, with their online accounting or stock keeping system, to largest internet retailers, every organization needs data, every organization produces data, and every organization essentially runs on data, right? So those organizations that are able to manage, govern, secure, and adapt effectively and be able to leverage all that data are the ones that will thrive in this new economy. Of course, it's one thing to be able to gather, collect, and manage all that data, but it's a whole different story when we're talking about making decisions based on data. And that's where data analytics comes into play. Traditionally, we have dashboards and reports that support that awareness of how things are, the current state of the business. Business intelligence and visualizations that strengthen the role of the knowledge workers with some informed insight about the data and about the business. To some of the newer emerging technologies like augmented intelligence that can help businesses discover information and patterns that even experts, subject matter experts, may overlook, right? So that's a new field that Microsoft actually just made a whole bunch of announcements around augmented intelligence, and it's really cool how augmented intelligence can really help not only in collaboration and looking at the data differently, but be able to get some patterns and insight that it's just difficult to see in a flat screen, right? It's when you're immersed, quote unquote, immersed in data, it really, really highlights some of those patterns and aspects of the data. So I encourage you to look at some of the augmented intelligence work that Microsoft has done. Really great stuff. So while analytics is important, it's increasingly evident that not all analytics are equal. Data science, for example, takes analytics to that next level, right? So from descriptive analytics to more predictive and prescriptive analytics. Because it actually enables some insights to be automated with a deeper depth and scale beyond the abilities of a human analyst, right? Nowadays, it's impossible for one person to handle and be able to analyze all the data that a business produces. And not only that, but also be able to consistently apply the apply some of the insights or derive some of the insights from all of that data. Sometimes people are there to put out fires, and sometimes those insights that were discovered, those patterns that were discovered previously, get lost because people focus attention to the other things. So there's a need to automate that insights as well, right? Using machine learning and AI to drive autonomous processes and decisions to enable organizations to respond more intelligently and faster, right? Just like with, like I mentioned, COVID-19 has changed a new normal for analytics and in business. With AI and machine learning, you can adapt and be able to get some of the insights for the new normal that's going to be out there, right, in the next year or so. But in order to fully achieve this automation and depth of insight, businesses definitely need to scale their solution, right? And they're not stuck in managing servers and managing infrastructure, managing security, and essentially being the business of managing data centers. And that's where the cloud really, really expedites, fast tracks that time to analysis. So, for example, the cloud has enabled companies to be able to start and scale projects easier and faster than they could ever could in an on-premises type of solution. We've seen with our own clients, all new initiatives for the past 2 years, every new initiative that all of our clients have had and where they need some support from us, all of them have been cloud native, right? Cloud first. On-premise, there are certain workloads that need to run and should be maintained on premises, but all of these new initiatives that were, there's no certainty of the business model, there's no certainty on the revenues that new initiative will bring or the cost to put that initiative in place. That's where the cloud really has helped expedite and be able to get those initiatives off the ground without having to worry about procurement and doing a deeper analysis of how much CPU, memory, storage you need. That's where the cloud allows you to scale as that initially requires and scale up, but most importantly, scale down when it's not needed. And give you a little bit more predictable budgeting or a more adaptive budgeting as the solution grows, right? But with a good sense of, what would it look like, a year, 2 years, 5 years down the road. So that ongoing shift to cloud native applications, including, collaboration like through Teams and file sharing platforms, put even more data within the reach of the analytics workloads. And the benefits offered by the cloud, as well as its proven security and reliability, has led to truly a mass migration, right? Even organizations that are bound by strict governance, compliance requirements to maintain that on-premises data management tend to take, at a minimum, a hybrid approach and use some of the cloud services in order to take advantage of what the cloud can offer. Like I mentioned, that scalability, grow as you need, scale up and scale down as needed as well, and see some of those cost savings that otherwise would require some capital investment. So cloud-based analytic platforms eliminate, like I said, the need of some of these CapEx investment, right? Capital expenditures. By deploying in the cloud, you can deploy faster, easier, and more flexible than a traditional data solution based on on-premises infrastructure, without that upfront high hardware infrastructure costs. And it allows you to iterate different designs, different architectures, and handle diverse types of data much more efficient than any on-premises solution. And the cloud just makes world-class performance and elastic scaling available to pretty much any organization, right? So if you need to scale really high, the cloud allows you to do that in a cost-effective manner. But most importantly, and this is what a lot of customers or a lot of companies that we talk to sometimes miss, and the value of the cloud is not just ability to scale on demand, scale up on demand, but most importantly, be able to scale down on demand, right? And there's some great stories about some companies that, had very high volume of transactions, in certain seasons, but then for the rest of the year, or the rest of the other seasons, they come back to more normalized workloads. And this is where the cloud allows them to scale as they need, don't lose that revenue, don't lose those customers when the demand is there, but then bring down their workloads, their infrastructure to a lower tier when you have that predictable, normalized workload. So this is something very important that I always bring up to our customers, because it really allows them to react to market situations and workload situations like this. But as the volume and variety of the data continually expands, modern cloud-based data services serve as the home for all the data. The workloads of all types, from enterprise models to BI sandboxes to predictive solutions, can be stored, managed, and provisioned all together, right, within the same environment, same security context. The cloud can efficiently handle different processing schedules, so scheduled or event-driven ETLs, as well as some on-demand self-service discovery type of processes. And it both delivers that enterprise-wide analytical solution, as well as more of the ad hoc discovery through a variety of data manipulation, data processing tools and services, different visualization, reporting, dashboarding tools, as well as more of those specialized data science tools for machine learning, AI, for those predictive, prescriptive workloads. Now, you know, many of you might have already heard or been in other webinars, attended some conversations where uh, the, they bombard you with many different options that are out there, right? So there's many things to choose from, and definitely there's endless capabilities for analytics in the cloud with whatever platform, whatever vendor you choose. And you might be wondering, like, so which one do I choose? You know, and you know, sometimes you may feel overwhelmed. Sometimes, you know, like, you know, is this strategy a good strategy? Is a single cloud, multi-cloud? Is it a third-party vendor the most the best decision to make? And sometimes this overwhelms some of these decision makers, and also uh, put you in a state of, you know, who do I listen to or what do I do, right? And you know, you're not alone, and you're not wrong as well in those the way you feel, right? That's right now we are in that age where there's truly an explosion, not only of data itself, but an explosion of capabilities, explosion of options out there. But because of all these choices, there's some situations that we've seen in our customers that I think it's important to talk about. And that is what brings me to what we're calling the paradox of analytics, with all of these different choices and all of the different approach, right, to data. So, for instance, you know, the ever-growing volume of data. You know, just taking that talking about that for a minute. Some of the industry analytics experts suggest that the data will quadruple between 2020, 2021 to 2025. So in the next 4 to 5 years, we're going to see data quadrupling. The rate the data is being generated, collected, aggregated will quadruple. And but the rough estimate is that less than 30% of all the data that's being generated will be analyzed. Doesn't mean that the rest of the 70+% is not useful. It just means that with the current methods, current approach, human beings, even with some of these machine assisted tools, can only analyze about 30% of the data. And the issue is not that, you know, organizations don't understand the rest of that data or don't find that data useful. It's simply, you know, put off or ignored to some degree. They know it's there. They know it may have some value. They just don't know how to get to that value or how to make it actionable, right? Which is the other part here. So in some conversations that we had with some of the Fortune 1000 leaders, you know, some of the comments around analytics and AI is that yes, those are top of mind in their investment, but what they have experienced is that some of these data initiatives can be challenging for many reasons. You know, cost, predicting the workloads, and really getting that return on investment on these data initiatives. But you know what we have seen, and based on some also on some surveys from, in this case, the Harvard Business Review, 80% of these leaders in top 1,000 companies, they struggle to advance their data insights, right? They're stuck in reporting and dashboards, but they really cannot advance and take their data analytics solutions to the next level, right? More than half of them blame the issue on data silos and all the overhead management around the data. And we're going to talk about data silos in a little bit, because that I think is part or the root cause of all these issues. But more than half also admit that, you know, they really don't treat data as an asset, right? They not because they don't think it's valuable. They don't think that data may help the business, but it's just that they don't have the capability of processing all this data, right? Either human capability, business process capability, or even the horsepower to be able to do that. So we're gonna talk about that in a little bit as well. But part of this underlying problem has to do with how the industry has approached data analytics up to now, right? For many decades, we've had specialized technologies, specialized tools and platforms, specialized approach patterns that we use for analyzing data, including traditional enterprise data warehouses, data marts, data lakes. More some of the newer patterns, which is delta lakes, kind of a combination of a data warehouse and a data lake. And those handle very specific types of data workloads and data capabilities, specific use cases of the data. And those patterns, those approach has allowed us to collect and analyze the data, from all sizes and formats, right? So those that approach and those patterns have been really helpful. But the problem is that because you have specialized patterns, tools, approach to handling data for very specific use cases, it has created these niches of data, right? Not only just niches of data, but niches of technology, and also, most importantly, niches in the skills required for those use cases. And this is what has led to the ultimate paradox of analytics. The more we apply technology to integrate and analyze data, the more silos we create, right? So the key here is that to be able to harness the power of data, we need to break down those silos without creating new ones, and be able to approach data analytics holistically, right? Don't think about enterprise data warehouse for this use case, data mart for this other use case, because that is what creates the silos. We need a holistic approach where you can apply any workload, any use case for any of these, any of the enterprise data, and don't have to replicate data, change the data, and create multiple silos or copies of the data. So on top of some of these approach and patterns, like traditional data warehouses or data lakes, organizations still need technologies for visualization, reporting, data science, data governance, etc. And these technologies have, like I mentioned, very specific use cases, very specific implementations for a particular need, and then them by themselves create silos. Not only silos of technologies, but siloed operations. The management, the governance around all of those are by themselves silos, right? So the task of connecting all of these systems really requires, specialized skills, building out new rules of engagement, new protocols, new processes, and most often duplicating data, which essentially creates, other silo, another wall around your data set. So it's a kind of like a compounding problem where not only you're creating silos of data for this type of use cases, but also now you're doing it for this particular tool or technology that you are implementing. So when you step back and consider a little bit that traditional approach of analytics, building a new system for each new business activity, new business initiative, business need, that may make sense at the time, and definitely it helped a lot of organizations get off the ground, right? However, as the volume of data has increased, and not only the volume of data, but the complexity and the variety of the data has increased, along with some of the newer complex systems and tools continues to increase, it really just adds more and more layers to this compounding problem. So there comes a point in which that the complexity of adding new technologies really outweighs the benefits of that technology itself, right? Because now you have to manage and govern that technology in addition to the data, the underlying data for that particular technology. So a holistic approach is the key to unlocking this analytics paradox, right? Because the goal for modern organizations is really simplicity and accessibility across the growing data needs and data capabilities. So again, bringing this back to some of the customers that we have talked in the past year and a half to 2 years it's really been, we have way too many vendors in our data analytics solution. We have way too many reporting tools. We have way too many ETLs, firing, integration between different systems. We have a division that only looks at data this way, and because of that, we only create a specialized data lake, database, data warehouse, or data mart for them. And all these silos going along. So when we talk about with these enterprise organizations that typically span multiple geographic locations, right? It's not only the complexity of the siloed data, siloed processes, siloed skill sets, but now you also bring into the mix some of the newer compliance and security requirements that have to do with all these different regions. And that's where we need to think about the holistic approach, right? Where we can simplify the architecture, simplify all the infrastructure, and have a one way to manage all different types of workloads and security requirements as well. So this is what we are calling the Analytics Continuum, which allows decision makers and business leaders apply a holistic approach to analytics, right? And the reason, because we're thinking about that and discussing this, is because it's very common for today that decision makers, business leaders, increasingly want to go beyond traditional reports and dashboards, right? They want to engage with the data, and they want to make their users, their frontline end users, frontline managers, to be able to use and leverage some of these new data sources and tools like big data, machine learning, and even AI to automate some processes, to make some business process more efficient. But most importantly, as we will see some customer success stories, be able to react and be able to understand their customers in the market more efficiently and faster than before, right? Instead of having a group that specializes and tries to see data and customers across all the organization, you want to bring that down to those frontline users, or those users that are more close to the front lines, to leverage these technologies. And in essence, what is called democratize tooling and democratize the data to make better decisions and take actions a lot quicker. Of course, with security and governance in place, right? It's not going to be the Wild West that open up the floodgates to everyone. It is really a more managed, secure way of doing it with this Analytics Continuum. So, but we need to be aware that this may require technology, and a combination of technology, processes, and skills. And that's where we're going to talk about how Microsoft, with the Azure Synapse Analytics offering, really brings all of that together in a more holistic way, right, in this new continuum. So this new approach in Azure that Microsoft has put in place allows for this more holistic experience to derive business insights. Microsoft has done a really great job on re-architecting the operational in analytics data stores to take advantage of the new cloud-native architectures. This is a fundamental shift that allows organizations to maintain consistency in their tooling, consistency for developers, which is very important, right? In the languages that are required to be able to access this data, and be able to eliminate silos in technology, skills, and data, right? All three components: skill sets, technology, and data. Those are the three main things that we always talk about with our customers. That it's great you have new technology, it's great that you have data, but you have the right skill set, right? Or you have the skill set, but you don't have the right technology to do that. So decision makers from across the organizations now are better positioned to access and understand the insight they need, and also the tooling and skills that their workforce needs to enable them on this new analytics continuum. So at the core of this solution that Microsoft has put in place is Azure Synapse Analytics. And we can define Azure Synapse Analytics as a limitless, and the keyword there is limitless, meaning you can scale to however you want it, a limitless analytics service that brings together data integration, enterprise data warehousing, and big data analytics into a single service, offering a truly unmatched time to insights. So you have a combination of your traditional enterprise data warehousing, a more modern big data type of approach to data analytics, along with the security and governance into a single offering. With Azure Synapse, organizations can run the full gamut of analytic projects and initiatives, and put data to work much quicker, more efficiently, and securely from any data source within the organization. Most importantly, Azure Synapse combines capabilities that spans, the data engineering, ETL, data modeling, machine learning, along with business intelligence type of reporting and dashboarding, and without having to create new silos of these tools and data, right? It's all in one place. We're going to talk about some customer success stories, including Procter and Gamble, but there's others like Walgreens, Mintra, that have achieved tremendous success already with Azure Synapse. And now that Azure Synapse is available globally in all their Azure regions, now every customer are able to access Azure Synapse in this whole holistic data analytics service. So far, we've talked about the value of analytics, the role of the cloud in modern analytics, the paradox that many of us face in our analytic environments, and what the ideal state to enable a more fluid continuum of data analytics that enable and empowers every user within your enterprise or your organization with Azure Synapse Analytics. So now we're going to dive a little bit deeper into Azure Synapse and describe how it works and the different capabilities within Synapse. So in summary, Azure Synapse provides a unified experience that brings together, like I mentioned, data engineering, data ingestion, data processing, transformations, modeling, big data analytics, and data warehousing at truly at a cloud scale. So instead of trying to put together, several services and create integration points between them, or creating yet more silos of data, silos of technologies, then Azure Synapse really brings all that together without you having to worry about all the configuration settings, security, handoffs between different services. in this unified experience, and truly gives you that limitless analytics capabilities in a single service. So as you may be aware, it will simplify all of these monotonous, what we call data chores, right? That are necessary, but are just too cumbersome, too time-consuming. When we're talking about securing data pipelines, providing the right permissions to users, to services, putting firewalls and firewall rules and networking to support all this traffic, and many other things, right? That are just a big part of that initial overhead that a lot of organizations have to go through, just so that they make an environment available to end users to produce and do any type of data activity, right? And derive insights. So with Azure Synapse, all you do is secure one service in one area, and that is the Synapse Studio that we're gonna look into. And then, the Microsoft Azure team takes care of all the rest. So behind the scenes, there's a lot of automation when you provision in Azure Synapse environment, and all of these configurations, security rules are taken care of for you, right? You don't have to spend a lot of time integrating those together. So, Microsoft heard all these challenges about just putting together all the different components to make an end-to-end solution, and they've listened to many customers and all the feedback, and they essentially have delivered on this through the Azure Synapse offering. So creating an analytics service that unifies all these silo divided worlds and redefines what capabilities an analytics service must provide is a result of multiple years of development and research that Microsoft and Azure team has done. They've set out to re-architect and create what they call the next wave of query processing for modern workloads. Because they're aware that the current workloads require not only the traditional workloads using like SQL, but also more specialized in scalable ways with Python, R, Scala, some of these newer programming languages that leverage technologies such as Apache Spark, which is an in-memory platform, and another platform like Hadoop, Databricks, and many other third-party components there, like or platforms there, like Snowflake. And they saw that customers really need that cloud-native analytics service engine and that converged with big data and data warehousing. So they could use pretty much a limitless scale on structured, unstructured, semi-structured data sets. And the result of all this development and research and feedback resulted in the new cloud-native distributed SQL engine that powers Azure Synapse behind the scenes. And with this deep integration of Spark and SQL engines, along with some NoSQL engines, Azure Synapse is really enabling a level of collaboration among data professionals that previously was really not possible or cumbersome, right? And when I talk about collaboration, for example, we're talking about your ETL team, your data engineering team, your data modeling team, all of them working on different versions and flavors and shapes of the data, perhaps with different technologies, tool sets. And then along comes the data scientists, right? And all your statisticians and your machine learning AI type of developers, that all of them has some level of collaboration, but that collaboration is not fluid and creates all these different silos that we talked about. So with Azure Synapse, now it is a single development experience single version of the data, single set of or a holistic set of tooling that is available for all of them, right? Not just data scientists, not just ETL, data engineers, and modelers. So given this, range of functionality, which is really a big range of functionality, that, as you will see shortly, available in Azure Synapse, it's really nice to have a choice of how you allocate and consume resources as well, right? So it's not just the tools that you use, but also the horsepower behind those tools. And it's great. Azure Synapse has a great way of managing and helping you manage the budget and the cost associated with these services and resources. So one of the ways is through serverless computing, as well as dedicated computing, right? Or serverless dedicated resources. And there's two models there, serverless resource model and the dedicated resource model, which allows you to have more flexibility and better management of your budget. So if, for example, if you have or you need more predictable performance and predictable cost, you can create dedicated pools of compute power, specifically, for example, dedicated SQL pools to reserve the processing power for data stored in SQL tables, right? Give you that relational view of your data. But if you have more unplanned or unpredictable workloads that sometimes burst or spike, then you can use the always available serverless resources, like the serverless SQL endpoint. And essentially, those are resources that are not just sitting there, consuming time and cost, right? They're there waiting for these workloads to use them, and while they're not in use, you're not being billed for them, right? You're only billed for the time it takes to process that data, and that is what they call the serverless resource models, right? And serverless SQL endpoints, for example. So I'm going to dig now a little bit deeper into some of the features available in Azure Synapse, and then talk about how to bring all this together to optimize your data analytics. So with that said, we're going to take a quick 5-minute break and stretch your legs, get some water, some coffee, and then we're going to come back and dive a little bit deeper into these features in Azure Synapse. And then after that, we're going to work on the hands-on lab. So I'll talk to you in 5 minutes or so. All right, so we are back. And if you have any questions or any comments, you can add them to the Q&A section. It should be on the top right. There's a little like question mark icon there. And just post any questions, comments that you may want to write up there, and I'll try to answer them throughout the workshop today. Also, if you look at in that chat window, Madison from our team has put there some links to make sure that you have the information to register for the lab environment. You will need to set that up ahead of time. It will just ask you for your name, an email address, and it will send you either a link or it will automatically provide you with an environment to connect to. So make sure you have that in place as we go along. So in about 30 minutes or so, we're going to start that lab portion. So with that said, let me continue on our presentation and talk a little bit more about some of the features available in Azure Synapse now. So first things first, right? Top of mind, security. So the quest to break down the silos and empower all users with access to this new continuum of analytics, it really asks the question, right? How can we secure and how can we govern all of this? In Azure Synapse Analytics changes now the role of your IT team by providing well-managed tools and services that support effective best practices among business users, right? And by that, I mean all the security features that you will need to be need to put in place for any new type of technology, any new type of platform and solution. So the way that Microsoft and the Azure Synapse team did this is by building data protection into the fabric of the service itself. So it is not an afterthought or an add-on. It is actually a core part of the Azure Synapse Analytics solutions. So right out of the box, when you provision a Azure Synapse environment, you get a comprehensive approach to security, all the way from access, authentication to proactive protection, proactive threat protection, and compliance. And because it's built in Azure, that means that you don't have to, deploy updates, patches, releases. It is automatically, you get all of these updated threat protection, compliance features immediately as they are rolled out, right? So that is a great solution for managing security, which has been a lot of the what some of our customers have requested in terms of how do we maintain whatever tools, platforms that we put into place, right? Do we need to put a lot of processes, new skills on that, or what can Azure Synapse offers? And as you can see on the slide, it covers everything from data protection, data masking, encryption, tokenization with Azure Purview, as we're going to talk about, access control and with Azure Active Directory, and other or other authentication methods, their own authentication provider, network security, threat protection, and isolation, right? So everything is defined within a boundary, network boundary within the Azure Synapse environment. So Azure Synapse provides a managed virtual network or managed virtual networks that allows you to connect your data pools or data storage seamlessly and keeping you compliant. This way, your team doesn't have to do the specialized work of setting up, maintaining the network, right? Once you provision the service, it generates or creates its own network, different network rules, and that allows you control access to any data pool within this environment. They also made it possible to easily apply data governance policies through the native integration with Azure Purview. And for those of you who are not aware, Azure Purview is a new type of service, fairly new, that automatically discovers and classifies data assets based on what you have set up, and the rules and policies that you have set up, and provides end-to-end data lineage, right? So instead of integrating with third-party data lineage, data catalogs, and data classification tools, you can do this with Azure Purview, which integrates seamlessly with Synapse right out of the box. So talking about a customer success stories, Grab is a delivery and payments service that has a lot of a big presence in some of the Asian and I think some of the European countries. And they actually were just announced that they were going to go into an initial public offering soon. And Azure, they have been using Azure Synapse for a while, and it has allowed them to not only access the high volume of data and high rate of the data that we're getting, but also, most importantly, be able to meet all the data security and sovereignty requirements across some of the countries that they were deployed. I think it's about 8 countries in total, but I think they have expanded beyond that now. And that is because, as you may know, some of these countries have more regulations around where the data resides for their constituents, right, for their citizens. So that was a very important customer success story that I encourage you to look up on their website and read a little bit more in detail. So in terms of data integration, as we see from our own customers, but in general, many companies across the world, one of the areas in any analytical solution is bringing the data together and integrating them, being able to report across multiple disparate systems, right? Disparate data sets. So, traditionally, you have to create some type of ETL or ELT, extract, transform, load, or extract, load, transform, then load. And that requires specialized ETL tooling. But with Azure Synapse, now you can take advantage of the built-in data integration capabilities that puts everything you need at your fingertips and bring all these different sources together. As you will see in a little bit, the ETL/ELT tool that Azure Synapse leverages is Azure Data Factory. So with Azure Synapse, you don't have to instantiate in Azure Data Factory, create pipelines, develop pipelines there. Now those workloads, that development experience is built in to Azure Synapse, and we're gonna look at that in a little bit. And as you may know, with these data integration capabilities, like Azure Data Factory integrated within Synapse, now your users, your developers can choose on how to develop those data pipelines, those integration pipelines, from heavy coding, Python-based, SQL-based, to more of a low-code or no-code interface, which essentially allows them to drag and drop, just like you may be aware with SSIS and other ETL tools that allows you to drag and drop different activities, different tasks, transformations, and connect them and create a workflow, right, or a pipeline. Now within Azure Synapse in Azure Data Factory, the Azure Data Factory integration, you can choose to do a heavy code, low code, or no code type of development for your data pipelines. And you can also schedule them or trigger some of these pipelines based on events, right? To make sure that your data keeps current or that your data reflects events that happen, within your ecosystem, right? So as you may be aware, Azure Data Factory in the integration tooling within Azure Synapse allows you to have that familiar Excel-like, very familiarized interface that Excel provides, as well as you may also be familiarized with Power BI. And what you see here is essentially the low-code, no-code interface that you have available now in Azure Synapse. Again, this is a Power Query, which can be found in both Excel and Power BI, as well as some other tools that now Microsoft is implementing this low-code, no-code interface. So if you're not familiarized with it, and you have Excel, most likely, you can go to the Data and Connection section in Excel, and when you launch that, you will see this similar interface. So very similar, actually, it's pretty much the same. And that is Power Query. And if you're familiar with Power BI, when you go to that transformation or transform data screen, what it opens up is Power Query, which is the exact same interface that you see in Azure Synapse for the low-code, no-code interface. We're going to explore both during the lab. Now, with all these different sources coming together, you might think like, how fast and how real time can I get the data into my environment? And what the benchmark that Microsoft has put together is by scaling up their compute resources, they have been able to bring down latencies under 1 second for the 99th percentile of the workloads that they have tested. So, less than a second, analytics, which is pretty cool. When you're talking about those big volumes of data and a lot of these unstructured data sets that are now, or streaming data sets that are now available. So with that said, now let's talk about some of the capabilities on data warehousing to support more of the SQL type of workloads or relational type of workloads. And it used to be that data warehouses was a enterprise level solution. And it really took months, maybe even years, to get it up and running, to get the modeling right, to get all the data integration that needed to happen there. And the payback period was often measured in months or even years or even decades, right? We have customers who have an enterprise data warehouse that are still in development after almost a decade. And we have come in and really expedited that by migrating that into Azure Synapse and see really faster returns on their investment, right? But in today's world, right, that has to happen faster, right? We cannot let the business wait or invest in a solution that's going to take years or decades to realize the value. And this is where the elastic platform of Azure and Azure Synapse provides a very accessible, very easy to use, ready to use solution for any size or level of business. And it gives you all the features that you need essentially in a single tier and provides all the elasticity that is required to scale your workloads and optimize all your workloads while controlling your cost and removing all the silos that we talked about. So speaking about control, one of the interface that you will see in a little bit also in our lab environment is the Azure Synapse Studio, which provides a unified workspace for data preparation, data management, data warehousing, big data, ML, AI type of task and development work. This is a highly visual, code-free interface that truly works for any type of workload, any type of skill set. From data engineers that will be managing, developing data pipelines, database administrators that need to automate and optimize queries and data structures, all the way to data scientists that might want to build proofs of concepts in minutes rather than hours or days. And all of this in a web native experience that ties everything together, one location, one interface, one experience, to pretty much take advantage and be able to complete any type of data tasks that they need to complete, right? And we're going to look at the Azure Synapse Studio in a little bit as well. Now, in terms of performance scalability, it's great if you can provision and manage and secure, but how can you ensure that there's a consistent level of performance for the business users, for your clients, customers, or business partners? And Azure Synapse really makes it easy to scale your workloads as needed, and ensure that consistent performance and be able for you to meet your SLAs. There's several benchmarks that Microsoft and the Azure Synapse team collaborated with some third-party benchmarking organizations like GigaOM, where they did a benchmark using the test-h TPC-h, at a petabyte scale. And you can read a little bit more about that. There's a link on the slide, or I can make it available afterwards, where you can see all the research and all the scalability, the level of scalability that they were able to reach with Azure Synapse, right? And what they saw is that with Azure Synapse, with a 1 petabyte benchmark, they were able to see massive concurrency, in very high-performing queries and high-performing processing of the data. There's a whole research document around that it's on that link that I encourage you to read. But also, like I mentioned, not only be able to scale, and when we talk about scale, not only scale in, but also scale out. Essentially, make your, and then scale down as well, right? So scale in, scale out, scale down. And what that means is that if you need more processing power, you can scale in by making those nodes or those compute clusters, compute resources, have more, resources available, more CPU, more memory, and more I/O. You can also scale them out and distribute the load among multiple nodes and take advantage of some of these parallel processing and massively parallel processing platforms. And then, again, not only being able to grow and scale your workloads, but once those workloads complete and you don't need all of that additional processing power, then you can bring those down to normal, minimal, normalized scale. Right? There's some other customer success stories like ABN Armo, where they migrated an outdated Teradata system into Azure Synapse, where they were getting prepared to shell out a bunch of money to update and extend and expand their Teradata systems, licensing and hardware. So with Azure Synapse, they were able to not only migrate and expand their infrastructure that was required to support the massive growth that they were experiencing, but at the same time, they were able to realize savings of more than 70% than what they had originally allocated or budgeted for their Teradata upgrades, right? So this is, a very specific customer case story about how Azure Synapse allows you to scale, meet your SLAs, and at the same time realize savings immediately by migrating to Azure Synapse. So really, really great story. It's also out in the Microsoft success stories, and I encourage you to read more about it and some of the details, how they achieved that. So speaking of awesome scenarios, right? All of these customer success stories are great, are awesome. But how does Azure Synapse makes it possible to perform some of the more real-time operational analytics, right, for faster decision making and improved response times? So for this, it is really great. This is something I am like, I love it about Azure Synapse, and that is that Azure Synapse, the Azure Synapse team has implemented a very low cost cloud native implementation of what they call the HTAP technology, or hybrid transactional analytical processing, and they are branding this as Azure Synapse Link. And what this allows you is to tap into the real-time, transactional operational sources in your organization, and be able to immediately reflect the most up-to-date data, or almost immediate real-time state of the data in your analytical platform. Again, they are branding this as Azure Synapse Link. And what Azure Synapse Link does is that it finally breaks down the barrier that has long existed between the transactional, operational sources with your analytical systems, right? The Synapse Link, links your operational databases to Synapse Analytics in Azure by providing the ability to get immediate access and insights to that transactional data. So as soon as a transaction is recorded in your, application database, your CRM, ERP system, for example, it's almost immediately available in your analytical solution in Azure Synapse in a matter of seconds, right? Within sub-second to just a couple of seconds, in a columnar format that is better suited for analytics. Now, you may think, well, what is the configuration? What is all the management around this? And it is very as simple as clicking a button to enable a transactional or operational database to link with your Azure Synapse environment. So that way you eliminate ETLs, you eliminate data integration, pipelines, transformations. Everything is immediately available within Azure Synapse in a format that is optimized for analysis. So now, instead of what happened yesterday, last week, last month, Synapse Link allows you to understand what is happening now, right? And that is one of the biggest added values that I see with our customers when they're adopting Azure Synapse. They eliminate the overhead, the cost of development, and making the transactional data or operational data immediately available for reporting, analysis, data discovery, and some machine learning AI workloads as well. Now, right now, the Azure Synapse Link is limited to Azure Cosmos DB. And what I'm saying now, because they are in the process of making Azure Synapse Link work seamlessly with Azure SQL database, Azure database for Postgre, MySQL, MariaDB, and many other relational, semi-relational, non-relational database systems available in Azure. But right now, it's immediately available with Cosmos DB, and very soon, I would expect in the next quarter or so. I'm just estimating here, but it may be available with Azure SQL database, right? I would say at a minimum before the end of the year, it will be also available with Azure SQL database, as well as some other specialized database systems. So that really enables that real-time analytics with minimum development effort, with minimum overhead and management, right? It's always pretty much the press of a button. And then once that is enabled, that operational data database is then automatically and continuously made available through Azure Synapse. in that optimized columnar structure that I mentioned, and think of it as like a covering index. If you come from a SQL Server world, it allows you to not only get access to the data in more real time, but also in an optimized format, that columnar format that allows that for more analytical type of workloads. So again, no complex ETL pipelines or additional database compute resources to maintain. It's really, coming from your source directly into Synapse in a format optimized for reporting in a matter of seconds. So in addition to enabling real-time access to operational transactional systems, Azure Synapse also supports data that's being streamed, typically associated with IoT type of devices, and some other applications that constantly generate and stream data. And Azure Synapse, some of the initial benchmarks that they have done is that they're able to process up to 720 gigabytes per hour of raw data coming in through these streaming data sets, like an IoT devices, for example, through IoT hubs or event hubs, which previously you have to build a data warehouse or a data lake just to handle and be able to store and analyze that data set, or having to spin up event hub or IoT hub and event grid to be able to access, or Kafka if you're using Hadoop-based technologies, to be able to access that real-time data. So now it's already built in within Synapse. You can query streaming datasets right out of Synapse without having to spin up new resources, right? There's a very good customer success story with a company called TechnoAlpine. And TechnoAlpine manufactures snowmaking machines that for ski resorts, for example. And what they did is that they made these snowmaking devices, snowmaking machines, into smart devices with IoT. And they are able to stream in real time some telemetry out of these machines, and also telemetry on the environment, right? The weather, it's raining, cold, temperature, pressure, along with the output of these machines to be able to ensure that the quality of the snow that's being produced is top quality and meets the standards of their customers. And also, in cases where it starts to snow, turn off the machine so that they're not producing snow when snow is being falling naturally, right? And being able to modify, to change the settings remotely from the streaming data of these machines in real time. So that results in better quality of the snow. That also resulted in lower cost of operation and maintenance of these machines. So very cool customer success story that I encourage you to also look into in the Microsoft success story. All right. So next, we're going to talk really quick about some of the machine learning AI capabilities within Azure Synapse. And then we're going to jump into talk about Power BI as well, and then into the labs. So with that said, let's take another quick 5-minute break, stretch, and get some water, coffee, and then we're going to come back to talk about machine learning and Power BI integration with Synapse. So I'll talk to you in a little bit. All right, so we are back, and let's continue our workshop and presentation. And like I said, we're going to talk about machine learning. Something that a good question that was posted on the chat was around the accessing the operational data sources within your on-premises or data sources that might be behind a firewall. And with the data integration feature, which uses or leverages Data Factory behind the scenes, it can connect to those operational data stores that are on-premises or behind a firewall in many different ways. You can use a self-hosted integration runtime, which acts sort of like a data gateway that allows Data Factory to connect to your on-premises data sources like SQL, Oracle, Postgre, MySQL, several other database systems. Or if you have already like a VPN or Express route with in Azure Data Center or Data Region, you can actually make use of either Azure hosted with private endpoint or private links, or another self-hosted integration runtime in your Azure environment. So there's many different ways to connect, but primarily the way we've implemented with our customers is through integration runtime, self-hosted integration runtimes, or through some type of VPN connection and some other infrastructure needed there. But yeah, you can do that very easily now. All right, so talking about machine learning, right? So we are going to just talk really quick about some of the capability. Like I mentioned, in most cases or in most organizations, the tooling and the platforms and the data itself has been siloed for data engineers, data modelers, data analysts, and data scientists. All right. It has because data scientists require a very specific set of tools and platforms and resources as well, right? So not just the tooling, the skill sets, but also the specific type of compute resources, such as Spark, Hadoop, Databricks, several other variations of these big data platforms, be it disk-based or in-memory based big data platforms. And all of these can be done within Azure Synapse as well. So the method that, or the feature that allows data scientists to work in Azure Synapse along with other type of users is the implementation of notebooks within the Azure Synapse environment and the integration with Azure ML to provide the compute resources and access to all some of the pre-built algorithms and models that are available in Azure ML. And also, like I said, the ability to develop your own notebooks in Python, Scala, PySpark, Spark SQL, to create some of these, predictive and prescriptive models within the same environments. You can use those pre-built models in Azure ML, or you can build your own. You can do some of the automation required around machine learning, such as scoring models, and getting accuracy and the accuracy for each of these models without having to do a lot of setup and a lot of configurations. All of this is just with a click of a button, leverage an existing model or build your own, train and prep your models right there from Azure Synapse. Like I mentioned, one of the development experiences within Azure Synapse Studio is not only a SQL-like or a low-code, no-code interface, but it also allows you to create notebooks. So this is an implementation of what you are familiar with, like Jupyter Notebooks, for example. Very similar, where you write commands within a cell, you execute those cells, and you can use your favorite language, pretty much, like PySpark, Scala, even C#, which is being used by certain machine learning modelers and data scientists. It also offers a great feature called IntelliSense. If you're familiarized with SQL Server Management Studio and also with Azure Visual Studio, it allows you to complete some of the coding that you're doing by looking at the keywords that you're typing, and it automatically suggests the auto-completion of that code. Really cool stuff there. Not only notebooks are available and used, but it also uses some or supports some data standards for data types and languages, as shown in the slide, right? So Python or PySpark, Scala, C#, SQL, but also supports the specialized data formats like some CSV, JSON, Parquet, which is what we use typically with our implementations, org, CSV, like I mentioned, and then some unstructured or semi-structured data sets, including videos, sound bites, images, etc. Furthermore, the Synapse engine also allows for automatic ML data exploration to allows you to get the best predictive models possible. So if you are new to machine learning, or you are not certain about which model, which algorithm, which technique you should use, you can actually make use of the automatic ML feature, and it will automatically score for you the different algorithm models and give you the accuracy that each of one provide, and then you can pick and choose which one is better suited for your use case. All of this, like I mentioned, is you access all this through Synapse Studio. You don't have to install anything. You don't have to get a specialized computer, a specialized workstation. This is all within Azure Synapse Studio, which is web-based. So there's nothing to install. There's nothing to configure. Everything is pretty much built in with Azure Synapse Studio. And this is great for those users that perhaps don't have a formal training in data science and big data. They can actually start using or leveraging some of these machine learning models and big data tooling within Azure Synapse Studio. Of course, more specialized workloads, more deeper analysis or use cases may require a formal data science training, but even those specialized data scientists, statisticians, they can make use of this same tooling with Azure Synapse. And like I mentioned, it supports that code-free ML scoring, right? Everything with a click of a button, you can send your data through AutoML, and it will give you back the scoring to choose the best model possible. So this really enables pretty much anyone in the organization to create and access intelligent predictions. So data scientists or some advanced users may create some of these predictive models and allow them to be leveraged by the entire organization. So truly democratizing machine learning and AI. There's a specific customer success story again with AmerisourceBergen, and if you're not aware of who they are, they have a very large market share in the sourcing and distribution of pharmaceuticals in the U.S. I think the last number was about 20% of that market, and they really needed a way to centralize all of the predictive analytics for their business users and allow those users to make use of those predictions. And with Azure Synapse Analytics, they were able to provide a self-service platform that the company uses now to predict some of those better business outcomes, all the way to frontline workers that may require perhaps what is the volume of the merchandise or the pharmaceuticals that will be required to be dispatched, everything from the supply chain management to distribution and all of that. So a really great customer success story that you can read on the Microsoft Azure Synapse website. So now that you have this environment, this capability, now you really need to be able to understand the data, and a lot of this, the way you will leverage all this has to do with also the maturity level or the stage that your organization is in terms of an analytics mindset. So typically, most organizations start with looking at what happened in the past and essentially looking in hindsight, right? What happened yesterday, last month, last year. But as you grow or you go through that analytical journey, then you go into more of the insights and understanding not only what happened, but why it happened, and looking at those causal factors. And we do this, we work with our customers a lot using causality analysis to understand why something happened. What are the causal factors for a particular customer decision, for a particular customer preference, etc. And then once we understand those driving factors, those causal factors, then we can really help organizations understand what will happen, what will be the decision of a customer or the customer preference, in the next 3 months, right? Will they buy this particular style, color, product category, etc. And get into more of the predictive analysis, right? And not just like customer centric, but also internal processes, right? What will be the revenue? What will be the profit in the next quarter, year, etc. And this is all driven with a combination of descriptive analytics, causal analytics, in combination of predictive analytics. And then the more where I think customers see the most value, which is how can we affect? What are the things that we can put together to affect or to drive a particular behavior? And essentially, how can we make it happen? And that is the, kind of the pinnacle of every analytical journey, which is the prescriptive analytics side of things. How can we impact, or how can we influence a behavior, right? For a customer to buy X, for our budget, our profit, or revenue to reach a particular goal. That could be, for example, for some businesses, increase prices, to package or bundle other products and services, perhaps to fine-tune those services, products to some of the emerging customer preferences. So a lot of these things has to do with looking back, but also looking at what affects it and how we can influence those factors, right? Very, very cool stuff. We do a lot of that work with our customers, with our causal predictive analysis. And if you want to learn more, we'll be happy to talk to you about that. So, so now, not only you can make use the machine learning and AI to do some of those predictions or those type of prescriptive type of analysis, but then for looking at the big picture, right? One of the great features that the Azure Synapse team enabled was the integration with Power BI, and this really allows you to take your analytics, your BI to the next level, because it allows you to, right from the Azure Synapse Studio, allow users to visualize this data within Power BI, within the Azure Synapse Studio itself, not having to go to like a Power BI site or your reporting portal, everything contained within the Azure Synapse environment. So this is a great, seamless integration, great capability that allows data analysts to derive some insights and how that self-service reporting capabilities within Azure Synapse. So, with Power BI and Azure Synapse, it really unlocks the big data in a way that would otherwise be impossible. And as previously mentioned, it is not uncommon for companies today to have, really large volumes of data, petabytes of data across the organization. In analyzing and extracting insights from such massive data sets, usually takes hours, if not days, right? So now with Power BI and Azure Synapse Analytics, not only you can use these big data tooling and features to analyze the massive data, but now you can also visualize it, right? Ingest it, process it, model it, but also visualize it. But how do you visualize petabytes of data, right? Some of these reporting tools just don't scale well. And because most of these tools, sometimes they have to, query the data, bring the data into their cache, and then use these cache data sets to be able to report and allow you to slice and dice your data. But one of the key capabilities that Power BI brings to the table, along with Azure Synapse, is that Power BI supports what's called direct query. And for those of you not familiarized with that, direct query allows you to send the specific queries that are required to satisfy a particular visualization or a particular analysis that's in front of the user through Power BI. So that this means that you hand off the processing power to the source of that data, right? You don't have to import it, cache it, and then have Power BI filter it and slice it for you. It puts that workload back to the source where it rightfully belongs, right? So if you're talking about petabytes of data, trying to read all the data and then filter it and then slice it, it's just not scalable. So that's why Power BI has this feature called direct query, which allows it to just send the queries that satisfy the visualization, the dashboard, bring back that data that might be already pre-filtered, and really minimize the amount of data that has to be brought back. And that results in very quick analytics. And there's some great videos and great studies where Power BI has been able to analyze, petabyte, trillions of rows in a matter of seconds, right? Using some of this direct query technology. So really cool capabilities with the Power BI integration and Synapse, and making use with large data sets, making use of direct query for that. And then some analysis that has been made in terms of total cost of ownership and return on investment. And in across the different customers, Power BI has seen that their customers experience more than 250% return on investment, 26% lower total cost of ownership, and overall 27% faster time to insights, with an increase of more than half, 60% increase satisfaction versus all of these siloed approach patterns that is currently in most organizations, right? So this is something to take in mind. This is a study that was made by the Forrester Research Group, and just take a look at what they came up in terms of the surveys and reviews that they have done with Synapse and some of the customers that have adopted Synapse so already, along with Power BI. And then in terms of a great success story, Procter and Gamble is a very great success story. You might be familiarized. Procter and Gamble manufactures, distributes products, consumer products like toothpaste, cereals, a lot of things that may already be in your pantry, in your kitchen right now, or in your fridge. And Procter and Gamble was able to enable account managers, brand managers, supply chain planners, analysts to make faster, more accurate decisions. The company was able to generate insights into these consumer goods, with over 500 million queries running over petabytes of data across hundreds of different systems and data signals. And this enabled Procter and Gamble to democratize access to the tools, access to the data, and be able to derive better, faster insights. So they leverage both Synapse and Power BI to provide really great opportunities that allow Procter and Gamble to understand the market better and react faster to changes in the market. So great success story. I would encourage you to also read that on the Microsoft success story. All right, so just to let you know, Azure Synapse Analytics and Power BI are both available globally across pretty much all regions. And new regions are announced, availability in new regions are announced, every other month or quarter. So, in the US, it's pretty much available everywhere in every region. In addition to that, Azure Synapse allows you to integrate with other third-party tools and platforms. Some of those are already in Azure, available through like appliance-based services, or just services that you deploy on VMs that already are available in the marketplace for you to deploy. So you don't have to do a bunch of configuration. You can just click a button, deploy within your Azure environment. Some others that are not in Azure, you can very easily integrate through some, so for example, web API or other type of integrations that might be available for those sources or those platforms. So take a look at their partner ecosystem. It's growing on a day-by-day basis. So really, really great partnerships with some of these third-party platforms and tooling. There's also some knowledge center available in Azure Synapse, and I'll show you when we get to the lab portion where you can access those. But you can have access to pre-built templates, samples, using SQL scripts, notebooks, and data integration pipelines that have already been built using sample data that you can learn from and actually, deploy in your environment and customize them with your data. So very cool set of knowledge entries there and samples and artifacts. In addition to all these success stories, what you'll find right now is that Microsoft is really making it easy for organizations to adopt Azure Synapse in many different ways. So they have some accelerators and some packages that really expedite and accelerate any type of migration from other third-party tools, platforms into Azure Synapse. For example, there's some packages, some accelerators with Click and SAP and Informatica. There's a bunch of information online. We can send you some links if needed. But you can find that there's accelerators to migrate and integrate with Click. There's also integrations or migration packages with Informatica, Teradata and Netezza, some of these other platforms. And then also with SAP, like I mentioned, right? Now, there's a special offer that you can take advantage right now if you're thinking about implementing Azure Synapse, and there's a almost 80%, I think 76% discount, yeah, when migrating to Azure Synapse from now until end of May. So if you're planning on implementing or adopting Azure Synapse, perhaps it's great to talk to us or talk to your Microsoft Azure representative and see where you can take advantage of these offers by starting to implement Azure Synapse and taking advantage of those discounts, deeply discounted packages right now. All right, so with that said, let's jump on our hands-on lab Um, if you haven't done so, please look at the links that are available in the chat section or the Q&A section that Madison made available there. And make sure that you deploy the environment or launch your lab environment. So if for those who haven't done so, and also just to get a little bit of stretch, we're gonna take a 5-minute break again before we start. So we can start with a fresh mind, stretch a little bit, get some coffee, some water, and then we're gonna proceed with the hands-on lab. So I'll talk to you in a few minutes. All right, so let's get started. Again, in our hands-on lab. So yeah, let me make sure I am. So did was everybody able to connect to their lab environment? If not, put your any question, any issue that you may have in on the chat, and then we can help you with it. Now, let me share my other screen, which is this one. Yep. Let me close on that. Close on that. All right. So actually, give me 1 second. I need to find my my lab link. You should get a email. You should have gotten an email letting you know that that a lab environment is available. So I want to make sure that mine is available. All right, and all right. So I have my environment available, and I'm gonna open it up. All right. So if you should have gotten an email similar to this one that I got saying that your lab is available. And then you will see that this environment will open up. Now, on the left side, you may see a, the VM session is off. So what you need to do first is ensure that your virtual machine is up and running. Make sure that it's in a running state. And then once you turn on your virtual machine, we will allow you to reconnect. Now, that is a virtual machine that Microsoft has made available for this workshop, and that has everything that you need, right? So your Power BI tool, desktop, and also the Azure Portal that will allow you to connect to your specific lab environment. Every user that registers gets their own lab environment, which is good for about 4 hours, depending on the time you launched it. Total of 4 hours. And I think you can actually, within a 7-day period, re-register again for another lab environment that you can use for another 4 hours if you want to review the same steps we just did. Now, in terms of when it asks you to log in, the login information will be here under your environment details. If you click there, you will see the username you will use, which will be something like onmicrosoft.com, and then the password that you're going to use for that. So I'm going to stop sharing because I don't want to share my credentials. I don't want anybody logging in and changing stuff while I'm presenting. So I want to stop presenting. I'm going to get my credentials and apply them into the VM, the virtual machine. All right. So now let me share my screen again. And you should see something like this where it will be an ODL_user and then your specific user, and then the password that is in that environment details. So I'm going to click sign in. I would say yes, don't show again, and keep signed. I would save the credentials in case you might need to re-enter them. And then what you will see is that this landing page, which is the Azure Portal, right? You're logged in with those Microsoft Azure Lab credentials. And you will see a resource group called the Synapse AI AD with your specific user ID. If you don't see this for some reason, you can go to on the left side, you can go to like dashboard, or you can go to home, and then you will see this available. So we're going to open the resource group just to show you all the services that are configured for you within this lab environment. In this case, we have a Synapse workspace, we have a Spark pool, and then a SQL pool, in addition to a data lake in a blob storage account and a Databricks service. Now, before we go into the labs, let's make sure that your Spark pool and your SQL pool are on and running. So let's click on Spark Pool and make sure that this is not that this is running, right? The status is succeeded, is deployed correctly. So that would mean that it will be available for us. If you go back and click on the SQL pool 01, this one I believe it's paused by default. So let's go ahead and click on resume. So let's click on that resume button up here. And are you sure you want to resume? Yes, I am sure. If you need to, you can split out the environment lab section by clicking on this split window section right here. Hopefully you can see it. It should be right here. And that will free up that the instructions, and you can like move it if you have two monitors, move it to the right, and then make use of a larger environment within your screen. So we're going to click home. Just make sure that it is in resuming. So it takes a while, it takes about up to 5 minutes sometimes. So by the time we get to it, it should already be on. So that will eventually change into running. All right, so now that you understand, what we have running behind the scenes, the next thing will be is to launch your Azure Synapse Workspace. So that you will see here, one of the resources or services that's available here is called a Synapse Workspace. So we're going to click on that. And once we get into that Synapse Workspace blade, you will see that all the associated compute resources and storage resources. But what we're going to do is we're going to launch the Azure Studio. I already got the message here that my SQL pool was successfully resumed. So be on the lookout for that. Make sure it's on. So let's launch Synapse Studio by clicking on this link here. It says open. Or you can actually click on this link here as well. But I'm going to click on here. And this will launch our Azure Synapse Studio interface. I'm going to do a quick walkthrough so you can see what different areas here. Here it says we asked you for accepting or rejecting cookies, so make sure that accept. It requires cookies for you to run. And if you are, you may be able to run this from your own laptop or desktop's browser, but I've seen some issues where even if you accept cookies, it doesn't run. So you have to use this Azure Machine Learning for this environment, the lab environment. Once you deploy this in your own subscription, you don't need this virtual machine, right? You can connect directly to it from your own laptop or desktop. All right. So with that said, once you launch the Azure Synapse Studio, you get this landing page where, like I mentioned, if you go to the Learn section, this is where you have a bunch of knowledge center-based learning, so samples, galleries, and then some guided learning as well. So this is a good link to look into once you deploy it to start learning. And then you have some shortcuts to some of the areas that we're going to analyze in a little bit. If you look on the left side, you can expand this and you get the labels for the icons. So this is your home, essentially your landing page. Your data section, which is where you will find your databases that are hosted by the SQL pool, your SQL pools, and then your linked services. In this case, could be Azure Blob Storage or Data Lake Storage, as well as some of the data sets that you develop using the integration pipelines, right? Specifically, these are similar to what you will see in the Azure Data Factory datasets. The other section is develop, and this is where, like the name implies, you will develop SQL scripts, notebooks, integration data flows or mapping data flows, and Power BI data sets and reports. So data is the connectivity to your data. Develop is the connectivity to the development environments and development artifacts. Integrate, like the name implies, this is where you will develop your integration pipelines, similar to in Data Factory to your data pipelines, in data flows, etc. The monitor section, a tab allows you, like the name implies again, to monitor all the executions that, of your integration pipelines. And you will see here, pipelines that were manually triggered or triggered on a schedule basis or triggered by an event. And then some other configurations, like I was talking about integration runtimes. Here, if you have self-hosted integration runtimes, you will see them listed here. And those self-hosted integration runtimes would allow you to connect to on-premises data sources or data sources that are behind a firewall, right? Without the need of a VPN. And then you have the Azure hosted, which you can have more than one. There's always a default integration runtime called auto-resolve, but you can create a couple more, several more, and tie those to a private endpoint. And what that allows you is to connect to on-premises networks where there's a VPN or some type of express route without the need of a self-hosted integration runtime. But in some cases, you also use self-hosted for some private networks and be able to reach some private networks within Azure or any other cloud environment. So we can expand on that, or you can send me any questions later if you have about that. That's a workshop by itself, just understanding some of the different examples in a webinar that we have coming up on that. And then manage, you can see the different resources you have. In this case, we have a SQL pool along with a built-in pool that comes with Azure Synapse. But if you want to have instead of a serverless, right, pool, you can have a dedicated pool where you know exactly the performance you will get. And this is the size that in this lab we are using a DW200C. And then there are different tiers that you can scale up or scale down as needed. All right. So something else I wanted to point out is that here you will see the integration with Azure Purview to do all your data classifications, discovery, exploration, and be able to secure your data seamlessly within Synapse. All right. So with that said, let's walk through the Azure Synapse Lab, and we're going to go into the exercise 1, which will allow us to explore data. You should already have resumed the SQL pool, so make sure that you have that. And the first exercise is we're going to go into the linked services. We're going to explore our data lake storage, and specifically a folder in our data lake storage called WWI, and explore some of the data using the SQL endpoint or the SQL scripts. And then we're going to do the same with a notebook. So the first thing is we're going to go back to data, and then we're going to click on linked, the linked tab, and we're going to expand our data lake storage Gen 2. Then we're going to expand the workspace. It says primary workspace. And in this primary workspace, we will see that WWI, which stands for Worldwide Importers. That is a sample database that Microsoft makes available to explore some of the functionality in SQL and some other functionality in Synapse. And what they did is that they already exported the data, some of the sale data, into two different folders. One folder in a CSV format and another format in the Parquet format. And we're going to explore the differences between exploring data in CSV versus exploring data with Parquet. So we're going to start with the CSV version of our data. And the first thing we're going to do is we are going to, let's see. Yeah, let's explore the fact sale CSV real quick. Go to, actually, I think the exercise starts with Parquet. So let's start with Parquet first. Let me not just jump ahead. Let's start with Parquet. So let's go to the fact sale Parquet. Let's go to the folder, 2012 folder, quarter 1. And then let's find the first day of that year, which is January 1st. As you navigate in this folder structure in the Parquet folder, remember, you're going to see that there's a file with an extension of .parquet. So that this tells you that this is a Parquet version of the data. And what we're going to do is we're going to right click on that file, and we're going to click on new SQL script, select top 100 rows. So once we do that, you're going to actually hide this on the right if you click on this icon, properties, so you can get a little bit more real estate. And you can also collapse this on the left in here, so you can get a better, bigger screen size in your SQL script. So you can see here that as soon as we right click on that file and select the top 100, it automatically generated the script for us. Select top 100 star from open row set bulk read from this file that's located in this location, and we're going to use a format of parquet and return that in a result data set, right? So let's just click run, and we should see that we will be seeing here in a little bit of time 100 rows of data from that CSV file. That may take a couple seconds once we do it, the first time we do it. And in my case, it took 10 seconds. I'm going to run it again, and we should see that take much quicker, right? Next, actually sub-second response. And the reason is because it creates some cache of all the data that you're reading, the files, and the data sets that you're bringing back into SQL. So first time, couple of seconds to read, parse the data. Second time, really quick response time, right? Once we have that data cached. Now, if you look at the results set, you could see that we not only got the rows back, but we also got the header information. And the reason that we were able to get the header information is because the parquet file format stores both the data and the metadata about the data, right? Or data about the data. And essentially it stores the data itself, and it stores the column names, and even actually it stores the data type of each of these different columns. So that is a great format when you want to keep all that intact, and think of it as mini tables, mini SQL tables stored in files that has the column names, data types, and actually also stores some statistics and profiling about the data, and allows you to retrieve from a large parquet file a subset of the rows without having to read the entire file and then filter data. It actually allows you to read the specific rows that you're interested on. So a very optimized file format to use with large volumes of data. All right, so now that we have that, we can manipulate this query as we wish. Instead of a top 100, we can do a top 8 account star and run this again. And we should see, for this particular file, we should see that we are bringing back just, 32,000 rows, right? But in addition to that, not only we can point to a specific file, if we wanted to, we can actually change this and bring the entire year worth of data. So what we're going to do is I'm going to delete everything from 2012 /forward. And what I want to change there is I want to change this query to be star / star. And what that means is it's going to bring all folders, all files within those folders under this structure. So in this case, actually, in the example, it's saying that we should bring, or pointing us to Q1. So you want to bring all files for Q1. We just leave the path up to Q1, and then bring all the Q1 month and all the individual days, partitions for those days, right? So let's execute that, and we will see that count increase substantially. So let's run that. And it will read the metadata for those files, and as long as all those files have the same structure, it will bring you that same structure that's common across all those files, or the representative metadata. So in this case, we have 299, actually 2.9 million rows of data across, hundreds, if not many thousands of files potentially, right? And that allows you, like you see, very quickly traverse folder structures in your data lake and get counts, get queries with relatively ease, just using a SQL-like script, right? A SQL-like syntax. And here we can do, where column 1 equals, X, right? So we can manipulate the script and only get to the data that we want. All right, so with that, now let's see how it works using the CSV format. So let's close this script, and we can close and discard. And we're gonna navigate all the way back to the WWI folder. So you can click in this section here, or again, you can go back to linked. You can click on WWI, and that will bring you back to this root folder, right? Root folders. In the next exercise, we're gonna explore data using CSV. So we're gonna double click on the CSV folder, 2012, Q1, and then the same, right? The same day. In this case, we're also gonna do a new SQL script, and we're gonna select top 1000. But in this case, if we try to run this, so let's run it. Okay, so in this case, yeah, it's giving some errors because it was not able to identify or infer the schema, right? Because CSV file doesn't store the schema. So in this case, what we're going to do instead is we're going to launch a pre-built script that we have available. I just wanted to show you that if you try this with a CSV, it may give you errors that is not able to handle the file because it's not able to infer the schema, right? So instead, what we're going to do is we're going to go to, instead of the link or the data section, we're going to go into the develop section. So it should be this icon here. And we have already a pre-built script that we can open called the exercise 1, read with SQL, right, on CSV. Now, if you see the difference, when we try to just select top 100 from a CSV file, it didn't know, what is the field terminator. It didn't know that there were header columns. So in this script, it already puts all of that for us. In this case, the path, the format, in this case, a CSV file, the field terminator. So this is a pipe delimited. So this is what's called a pipe. So a pipe delimited file. The quotation for some of these text fields or different fields, and then the row in which the actual data starts. So the first row of data will have the column names. The second row forward, that's where the data starts. So this is kind of the different configuration you have to do. And then in addition to that, it provides the schema that we should use, or it should use, to read that data. So if you can see the difference between Parquet versus CSV, with CSV, you need to provide, the format, the field terminator, field quotes, and the row at which the data starts. And in addition to that, you need to provide a schema. So that's why Parquet is better, because it stores all of that for you without you having to do this every time. So let's run this query, this script. And it's giving me an open row set. Let's see, let's run it again. Okay, my bad. So if you're getting this error, like I'm getting it, it's because I probably did not follow the instructions. And one of the instructions here says is that we need to change our connection to use the built-in serverless in the SQL on-demand database. So let's run that. And it will take, again, a couple of seconds. I think this one may take even a few minutes because it is, this is a serverless SQL pool. So it is getting the pool to turn on or to have that serverless environment, SQL pool environment up. And then once it gets that environment up, it will read the CSV files that are in this path. So this usually takes a few minutes. So let's wait for that to get up and running. In the meantime, let me check and see if there's any questions. Let me see. How do I start a VM? When I select the play icon, nothing happens. Okay. If you're having issues, yeah, make sure that when you go to the virtual machine, if it's not running, check the status, make sure it's running. If not, and if the start button is not working, do a refresh. Make sure that, sometimes it just takes a while for it to update the status. So click on the refresh button, and then if for some reason it says that it started but you're not able, so you go to the VM, like I am here, it doesn't allow you to log in, try stopping it or restarting it. That should definitely get it up and running. All right, let's see if there's any other question. I think that's it. All right. So let's go back to our exercise. So now it ran, right? So the same result as the same count, because it's doing a count, the same count, right? 2.9 million records. But you can see that it took 1 minute. And the reason it took 1 minute again is because it takes a little while for that on-demand SQL pool to get started and then be able to read the data. Now that the SQL pool, the on-demand or serverless SQL pool is up and running, if we execute this query again, it should be much faster. So it took 1 minute, 2 seconds. Let's see how much it takes once that it is on and it has already read through those files. Should take like half a minute or less. Let's see how much it takes. And yeah, so because I think we are all sharing that SQL pool, there might be, if everybody is like hitting this at the same time, we might be hitting on each other. Or I think actually this is a dedicated, well, a serverless environment, a SQL pool for us. Yeah, it's one just for me, so it shouldn't be the case. But yeah, it should take a little bit of time. Took less time, so 55 seconds. And if we run it again, it will take less and less because all that is cached and available. So it should take less. But the key understanding here is that Parquet is much faster, and having a dedicated pool is a lot faster because it persists all of these data sets in cache. While on demand, if you use it for the first time, it has to allocate the resources, and then it's got to read the data. And a lot of this might not be cached, so it will have to read the data again, right? So there's some performance optimization and performance benefits of using dedicated, of course, versus in on-demand. The difference is that with dedicated, you're paying for that dedicated compute power, versus on-demand, you're only paying for the time it takes for that serverless SQL pool to execute this script, right? So some definitely, if you want a consistent performance, you might want to use dedicated, but for those one-offs, ad hoc type of queries, you want to use the serverless on-demand. All right, any questions or comments so far? How does this work with other file types such as XML and JSON? Are they similar to Parquet? No. So with XML, JSON type of files, you need to potentially provide an XSD file, essentially a file that may give you that template of the structure of the data, but with a JSON format, it is self-documenting, right? It is a hierarchical structure that will allow you to traverse and find the different nodes or different levels of that JSON document or XML document. So you could provide a template file that gives you that, or Synapse is able to derive the different level, different nodes, or hierarchy of that XML or JSON document while it's reading and parsing to the document. Good question. All right, so we just saw how to read data that's in a file format using a SQL query, a SQL script. Now we're gonna see how that works using a notebook, right? So if you're familiar with machine learning, data science, you most probably have already worked with Jupyter notebooks or some type of variation of those notebook environments. And you most likely have worked with data frames, Pandas data frame, Koalas, which is the new optimized version. Or using Python, PySpark, in Scala data structure, right? Data structure. So, so now we're going to work with the notebook experience, and we're going to go back to the Parquet file. And instead of loading this into a SQL script, we're going to load this into a data frame in a notebook. So if you are not in there, so let's go back to the data link service and go to WWI and go all the way to the root folder. And we're going to go back again to our Parquet file format. So we're going to navigate to 2012, Q1, invoice date, January 1st. And we're going to right click, and instead of choosing new SQL script by selecting top 100 rows, we're going to say new notebook, and we're going to load that into a data frame. So when we work with notebooks, we need to work with a Spark pool. So let's make sure that we select from the top here a Spark pool, and that the language or kernel that we use is the PySpark Python. But as you can see, it supports Scala, it supports C#, and it supports Spark SQL. But in this case, we're going to work with the PySpark or the Python implementation of in Spark. So we're going to use a Spark pool using PySpark. Once we do that, then now we can do execute this cell. You have a couple of options. You can click on this icon here, run cell, or you can do Control Enter, and that will execute that cell as well. So Control Enter or click on that icon. And because this is the first time that we are connecting to the Spark pool, it is initiating a session for us in that Spark environment. All right. So that takes a little bit. While that is launching, I'm going to explain what's happening here. So, what we're saying is we're going to use the PySpark language. So this is like a magic, they call it a magic keyword to signal to the Spark cluster, the Spark pool, that we're going to use the PySpark language. Then we're going to assign, we're going to read from this path using from this file path, right, in this particular file that is using a Parquet format. We're going to load that and read the contents of that file into a data frame that we are calling df. So df is a variable name. We can say df1, df2, whatever we want to call it. And essentially that's the like a variable name where we're gonna load this data set into. Specifically, that's a data frame, right? So think of it as an in-memory table where we're loading our data. And then once we load that data, we're gonna display the first 10 records out of that data frame. So this is saying display from my data frame called df and limit to 10 rows of data. So the result that we should see here in a minute or two should be only 10 rows of data. Now, as part of the instructions, it's asking us to disable preview features. And you can look at the documentation here. What are those preview features that are available that we might want to turn off? And I think I should have turned that off before I run it, but we'll see. We'll run it twice. And you're gonna see two things, right? One is the results or the experience without the preview features. In the time it's taking to initiate a session and read that file in a data frame. So we're gonna see the differences. So one of the great things about Spark and this environment is the monitoring and the description of what's happening, right? Once the session is initiated, it will give you what's called the Spark UI and explain to you how that query or that data frame is being executed. In this case, it's generating two jobs. One is to load the data, and the other one is the get row method, right? And then you can see that behind the scenes, it's actually using the Scala and Java APIs. So the PySpark is an implementation on Spark that uses, behind the scenes, uses Scala. So here you can see that it took over 20 seconds, but it took 20 seconds to execute, but it took more than that to initiate the session. So I'm gonna turn on preview features, turn off. Because that's what the instructions say. So we're gonna see what the development experience looks like without those preview features. And then, whoops, it closed our notebook, but that's fine. So we're gonna go back to WWI and into the Parquet file, and we're gonna relaunch our notebook, load into a data frame. Most likely, it also disconnected our session. Just to make sure, you need to select Spark Pool 1 and the PySpark language or kernel, and then we're gonna execute that cell again. Three course. Okay. So let's see what's happening. Let's go back here. Make sure our Spark Pool cluster is on, and gonna refresh. It's on. And let's go back to our environment and Spark Pool Python and let's session fail. Okay. Let's run the entire notebook. That is interesting. All right, let me close that. And let's run a new notebook. And let's try running that again. Session failed. That's interesting. All right, so I'm gonna go back here. If you're having this issue, let's see, hopefully they haven't, when I increase this to like 30 minutes, just in case. It has been idle. I'm going to make sure that it is running. So saying it has 4 cores, cancel. All right. So what I'm going to do is actually I'm going to close my Synapse Studio, and I'm going to launch it again. It should have picked up a new session automatically, but I guess after we turned the preview features, it disabled our session and only made one session available. So let's go back here to our data and linked store, data lake Gen 2. In our primary, I'm going to go to WWI, Parquet, 2012, Q1, US date key, and we're going to create a new notebook. I'm going to load that into a data frame and make sure that it's attached to Python Spark, and let's try to run this, see if this time it works. And yep, so this should be working. So it was because we had that environment, that Workspace already launched, most likely it was holding on to that existing session, and it had assigned all the resources to that session. And this, so we had to close it so that it kills that session, and then launch the environment again to create a new session, which is what's happening right now. Now, and that's something to keep in mind, something important. So there's some, magic keywords like this one that you can use, and it's part of the management and governance, right? So when you have multiple teams using the same clusters, you may find that some team members may be running a very large script, a very large notebook that is consuming all the resources in your pool. So in terms of governance and management, right, you may assign different Spark clusters or Spark pools to different team members, the different development departments, or even users. Some users that really need dedicated pool of resources, you dedicate a pool for them. There's also a way to manage how many resources, how many cores and executors are being consumed by a notebook or by a session by some of those magic keywords, and you can look at what those are. But essentially, you can specify, your driver cores, your number of executors, driver memory, as well as your core or task nodes, and how much memory, how much CPU power or cores, right, that session is assigned. That way, if you know that there's other team members that might be running the notebooks in the same cluster, you can share and don't take over the entire resources, right? So it's initiating the new session, and as we can see, we will actually also execute and return the same results that we saw on the previous session. So let's let that run. And again, you can monitor that job and look at where it is at, and it returns the data. So now we have the data back, and you can see by default it gives that data in a table format. You can see here that we have a couple options. We have the table and we have a chart option. So if you click on chart, it will automatically try to visualize that data in just whatever format it chooses to. But in this case, we're going to customize that a little bit. I'm going to click on this view options icon on the top right of the chart. And in here, you will see that the different values or fields that you use on these different sections, right, of the chart. In this case, we're going to keep it as a bar chart. We are then going to change our key to be the customer key instead. So we're going to choose customer key for our key. And then for values, instead of the sales key that we decided to choose, we will choose the city key. Okay. And then in our series, we're going to leave that blank. In the count or the aggregation, we're going to leave that as a count. So this is a count of cities by customer. And we're just going to click the apply button. And we can see that it automatically rearranges that that for us, right? All right. So that is the the built-in visualizations that is available for us in within the notebook itself. And then you can change this as you wish. Change the values here to navigate the data. And we can go back to the table and change this as you wish, right? So now, if you wanted to hide this, there's this little icon here on the top that allows you to hide the results. So if you are, exploring the data and you have multiple cells, it doesn't get crowded. You can view the results, expand the results, and hide them as needed as well. And if you want it, you can clear the results, but then you have to re-execute to get back those results. But so these are some navigation items that you have available. Now, in addition to this, let's add a new cell, right? So how do you add additional steps or additional cells to execute, refine, filter your data? So if you hover over this line right here, you will see that two new options are being available: add code and add text. Right now, we're going to create another cell that we're going to execute some code. So we're going to click on add code, and it generates a new cell for us. And you can see it's called cell 2. In the lab instructions, you will see that we have a script that we can copy. So we're going to copy that. And here, we don't have, you right click, you don't have the paste option, but you can Control V. If you click Control V, it will allow you to paste that script. Okay. And in this script, it's very similar, but as you will see, we're no longer trying to read data from the CSV, from the Parquet path, as you can see here. We are reading the data from the CSV folder. And again, we specify additional options like what format, what is the separator, and if it has a header. And then we're going to read that into a file called data path and only retrieve the first 100 records. So let's execute that cell and see how fast can that be retrieved now that we're in the Spark world. Okay, something that I forgot to change is that that script doesn't have your actual path. So I'm gonna stop this from running, and I forgot to replace this, your data lake name, and your data lake name is essentially what you have up here. So it will be this ASA data lake. It's also available in your environment details. You'll see the name of your data lake. Again, this doesn't have, unfortunately, the copy function. So instead of right-clicking, you just select and then Control-C, C as in Charlie, and then highlight this, delete, and then Control-V, paste. And this path should be different, right? Should be your own path. So this ID that you see here may be different, or I think will be different in your case. So make sure that you put your appropriate environment. So now that we have that, let's run it again, and then we can see the results of this PySpark query. So yeah, so that's looping through all the different CSV files in this path and inferring the schema using this header equals true option, right? Because we're not specifying the schema, we're simply let the Spark cluster infer it. So that will take a little while to run. Depending on the volume of data that we're reading, right? In this case, it's not a lot, but it is a lot of folders and files that it's looping through. So it's taking a while. One of the benefits of using Spark Pool or a PySpark is that you are able to scale those reads and writes linearly with the compute power that you provide. Right now, our compute power is relatively small. If you look at the Apache Spark pools, we're using 3 nodes, so it's going to be 1 driver and 2 worker nodes, 4 cores, 32 gigs of RAM. So it's relatively good size, but it's small in comparison to some of the other options there with 32 cores and 256 gigs of RAM, and then also the number of nodes, right, to potentially dozens or even hundreds of nodes. So the more horsepower you provide your Spark pool, the faster it's able to return results, because it is able to distribute the reads for all those files in multiple nodes. In this case, we only have 2 executors with 8 cores that has been assigned to this session, and it took about a minute to return that data. Again, the nice thing about this is that if we run this again, let's run this again, it should take a lot less time to read that. So we'll see how it takes. So from 50 seconds, almost a minute, to down to 8 seconds, right? And the reason it was able to run this faster is because one of the major advantages of a Spark pool is that it loads these files and these data frames into memory, and now you're hitting a cached data set, right? So from 1 minute to 8 seconds. And if you run it again, it actually takes actually, let's bring 1,000 rows, and if I run this again, it should still take right around 8 seconds or less. Yeah, so even with 1,000 rows or 1,000 rows, it took still the same time, right about the same time, 8 seconds. So it scales linearly, and it also performs subsequent operations on the data much faster because it's in memory. All right, so with that said, let's close this and let's jump on the next exercise. The next exercise, exercise 2, is to build a Azure Synapse pipeline. I'm going to skip through some of this just in the interest of time, just to show you some of the highlights, right, of what I wanted to show you. And in this case, what the exercise is pointing us to is to read data from a CSV file. And it is using, instead of using PySpark, it is using Scala. So it is the same concept where you load data into a like a data frame. In this case, it's called an RDD. Similar concept of a data frame, like an in-memory table. And then it's able to display, read the data, and run it, right? So it's just simply the same concept of reading data from a file using SQL, PySpark, using Scala. Different language syntax, but same concept. All right. Then the next portion is talking about those data integration. So if we go to the integrate portion, you will see that there is a notebook already created. Sorry, to develop. There's also already a notebook already created called the bonus notebook with C#. And again, I'm not going to run through all this, but this is just an example on how to read data from in this case, a data lake storage file. and then import that into a in-memory object using C# syntax, and allowing you to define your own connection strings and be able to read data. In this case, we're reading 1,500 records, and then inserting this data back into a JDBC or a database table, and write to a Azure Synapse SQL pool table. So very cool exercise if you want to learn sort of the syntax with a C#. Again, similar concept: Scala, C#, PySpark. All right. Now, the next exercise I wanted to run you through is how to read data from a database, right? So in this case, we have a database that's a couple databases that are already created in some of these SQL pools. So we have our dedicated SQL pool and our on-demand SQL pool. And writing data to a database table is very similar to what you might be accustomed to in SQL Server world, MySQL, Oracle. Defining a table and then inserting data into a table. And the same applies with data coming from reading data from a table, right? So if you wanted to do a quick query here, we can read top 100 rows from this table. And in this case, it's going to use that on-demand SQL pool and return the data, in a table. And then we can do the same change to a chart and visualize this data into a more of a visual type of format, right? So, yeah, and then change this as we decide. So this is great. The concept here is that you may have data engineers, ETL teams that are reading or writing data to a data lake, perhaps reading data from a CSV, XML, JSON file, and then applying transformations like header, data type, applying some business rules, and doing some initial data cleansing, data transformations, and then making that data available either in a data lake, Parquet file format, or making it available in a more relational format that perhaps certain users might be more familiarized with. So for those users that are more familiarized with SQL development, you can just create a quick table, load the data to a table, or a view as well, and then have users query that data using the SQL language, right? So here I can do, for example, things like, where my customer key equals 228, right? I'm just going to grab one random, and I'm going to run that. And then we should only see sales for customers that has a customer key of 228, right? Same thing, we can do date based, where my invoice date between this date and this other date, where my product categories or my product styles are X, and just give those users that similar familiarized SQL-like environment. All right. So now the next exercise that I wanted to run really quick is the data integration point. Let's close this, and we're going to go to our integrate section, and we're going to expand our pipelines. So here, just like you are maybe already familiar with Data Factory, we can actually create integration pipelines within Synapse. So for example, in this case, I'm going to click on enrich data. And this enrich data exercise shows you how you can create pipelines that have some sequencing and sequence them in the right order. So in this case, we have two activities. One is called a copy data activity, and the other one is a data flow activity. The copy data activity like the description explains here, copies data from files that are in a data lake, perhaps, and does some renaming and then stages that data in another sink or destination. If you look at if you click on the white canvas, you can see that there's no properties. When you click on copy data, it brings up the properties and the settings for that activity. If you click on copy data and then go to source, you can see that it is selecting data from a Azure Data Lake store, and then it is syncing that data into a staging area in the WWI staging. You can see that the icon is a table, right? If you go back to data and you look at the tables, I think there should be already a staging. This is the, let me double check. This is using the staging dim customer ASA. And if we look at the data sets, where is that? Sorry, data sets. There is should be one called WWI staging dim customer. So WWI dim staging, WWI staging dim customer. So it should be here. So that is pointing to this data set. If you click on that data set, it's pointing to a data set in the SQL Pool 01 service under a table called WWI staging. So if you go back to the data and we go to Workspace and we go to SQL Pool 01, you should see a table called, we may or may not see it because I don't think it's created. It creates it automatically, but it may be there. And it is not there. So we're actually going to run it and we're going to create it. Yep, I don't see it there. All right. Now, so what this does is very simple. Gets data from a data lake, applies perhaps some mapping transformations, and then stages the data in a table, which is here in this sink. As you can see, it here it has the mapping, so we should see a table with these columns in this mapping. Now, the next thing it does is with this data flow, if you double click on that data flow, it will open the data flow, mapping data flow, that essentially what it does is it now reads that data from those customers. It also reads data from this file called the postal codes, and then it creates a join between those two data sets, right? And essentially it grabs augments the data based on the postal code and zip code, and enriches the data by creating adding a column, a city column, right? So based on the zip code, it will know what city it corresponds to, and then adds that column to the data set that is then later written into a two tables, a enriched customer data ADLS, data lake store, and then into a table called enriched customer data that we should see in that same database. Now, obviously, if you are using data that first needs to be copied from this activity, you need to sequence that. Make sure that this completes before this one runs. So that is the concept of a data pipeline, where you can actually sequence your data flows in such a way that it follows that workflow, right? In this case, we're using the on success constraint. So if you're familiar with SSIS, this is the same concept where you have, if this activity is successful, then proceed and execute this other activity. Then you can have other paths where if this activity fails, then do a separate flow of data. or if it completes, regardless if it is successful or fail, proceed with the next step. So once we do that, the next step will be to debug this, and essentially debug means run this pipeline interactively. So we're going to click on debug, and it will allow us to, select what integration runtime or what compute resources we want to run this with, and how long do we want this to execute for. So after 1 hour, it will stop running. So we're going to click OK. And that takes a little while for that. The first time when you execute a pipeline, it provisions or it resumes that CPU, those compute resources that run this pipeline. In this case, it's a Databricks based compute power that we have behind the scenes. And it's going to allocate the nodes, allocate the session, and then it's going to run this pipeline. So that again takes a couple of minutes. Of course, once it's running, it's faster because the session and nodes are available immediately. Right? So we're going to let that run while we move into the last exercise that I wanted to run you through, which is the Power BI integration. So with Power BI, if you look at the integrate section, at the develop section, you would see that there's a tab here for Power BI. And we already have a linked Power BI workspace where right now it's blank, right? If you go to powerbi.com within that VM and you sign in, actually, I'm not in the VM. I actually need to do it here. So you open a new tab within your VM environment and you go to powerbi.com. And then you sign in. It will automatically pick up the, should automatically pick up the user. Maybe not. Let's see. Let's make sure I am. So yeah, it picked up my user, right? Because the browser has those credentials, so it will automatically pick up that. If not, you will just have to provide the username and password. So if you look at the workspaces, you will see that there's a Power BI workspace specific to you for you, and if you click on that, that workspace is pretty much empty at the moment, right? So essentially, what shows up here, it's what will show up in this workspace here. Of course, here it doesn't have the number, the ID, because that's how it was defined without the ID, just Power BI workspace. So in our Power BI workspace, what we're going to do is we're going to create a new data set. And by what we're going to do is we're going to click on Power BI datasets and then click on this option up here, new Power BI dataset. So we're going to click on that. And oh, by the way, that data flow succeeded. So we're going to go back, check on it a little bit once we complete this. So if you don't have Power BI installed, we will need to install it. But in this case, we already have it installed. So we're going to just click Start. And it's going to ask us what data source we're going to connect to. Now, notice that we don't have to go into Power BI Desktop and try to select the right type of connector and provide a string, a connection string. It automatically picks up those data sources that are available in the Synapse environment for which I have entitlement. So this is all the part of the security and governance around Synapse, where a user that wants to create some reports, some visualizations, they don't need to ask for permissions to a database team or try to make sure that there's a firewall rule that allows them to connect to a database. All of that is integrated within the Synapse environment, and the DBAs, the admins of that Synapse environment, will already have that configured for them. So now I'm a user that I have entitlement to these two databases, and the only thing I need to do is select which data source I want to connect to, right? I don't have to worry about all the other stuff. So I'm going to choose SQL Pool 1, and I'm going to click on Continue. And what that generates for us is a data source connection string, a data set file that now that I can download. So I'm going to click on Download. And as you can see, it's downloading for me a PBIDS file that I'm going to open. And that opens in my local Power BI desktop. So that may take a couple seconds to launch. So that, again, launches Power BI Desktop. Today is the first time that I'm launching it, so it's going to take a couple seconds to get Power BI, the Power BI application up and running. Any questions or comments so far? Still getting the same session failed. Okay, yes, you might want to close the entire browser, give it a couple of minutes, and then reopen it. All right, so again, it opened Power BI Desktop from that file that Synapse created for us. It's reading the connection strings, and it is establishing the connection to our Azure Synapse SQL databases that are available, that are specified on that connection string. So the next thing I need to do is, for this purposes or this exercise, we're going to do is we're going to select Microsoft account, and we're going to sign in with our Azure Active Directory account. So in this case, it will be our Synapse account, our environment account, which you will find under your environment details. So click on that environment details. Copy the username. I'm going to paste it here. Next. And then copy the password. And then we're going to paste it there and sign in. All right. So now that we're signed in, we're going to click Connect. And what we're going to be able to see now is on the right-hand side. Before we do that, one more step. We're going to be able to see is the different tables that are available in that SQL Pool 01 database that was specified during the connection string configuration. And in this case, we're going to look for the WWI fact sale table. So we're going to select it, and we're just going to click on Load. And then you will see that, well, in this case, and then it's going to ask us, do we want to import that data, or do we want to do a direct query against it? In this case, depending on the volume of data, typically what you want to use is a direct query to take advantage of the power in the SQL pool in the Synapse environment, rather than put all that processing power and memory load in your local desktop or virtual machine. So we're going to click on direct query, click OK. And then you will see on the right-hand side in a few seconds is the table with the column names or fields that were defined in that, database table, right? So now we have all these. And then the last thing we're going to do is, for now, we're going to save this as a data set that then we're going to be able to publish and share for one or more reports in that data source. So for now, what we're going to do is I'm going to save this report, and I'm going to call it the whatever you want, Synapse data set, underscore fact sales, right? We're going to save it. Once we save it, then we are going to be able to publish this data set. So click Publish on the top side here. Before we do that, actually, there's two ways we can do it. We can click Publish, and then enter that email address and password, or you can sign in to Power BI, same thing, right? And log in with your environment details. So in this case, I'm going to use my environment details. So this is my email address. Keep in mind that yours will be different, will be unique. And then most likely it's going to ask us for a password, unless it cached our password. Windows cache our password and logs us in. So let's, it's going to ask us for a password. Yep. So I'm going to use that username. And in my case, it already has that cache credentials, but you may need to enter your credentials. So now that we are logged in with that user that has access to the workspace we want, we're going to click on Publish, and it should automatically prompt us to what workspace we want to deploy this. So we're going to deploy it to this Power BI workspace and click Select. And it's going to deploy that data set for us and make it available in the Power BI service. So again, if we go to if we go back to Power BI, powerbi.com, and you log in, and we do a refresh, we should see that data set in a blank report that it creates for us, right? So now that we have a data set published, we go back to Synapse. Let's click on Continue and close and refresh here. And you will see in a little bit, if we click refresh, you will see that data set, right, that we created called Synapse Dataset Fact Sales. Now, this is the typical workflow, right? When you as a data modeler or a data engineer wants to make data sets available for certain users, you can pre-publish for them a data set that then can be shared across many reports or across multiple users. So you don't want, typically with Power BI, you can define a report, and then with each report, you have a companion data set. What you want to avoid is to have, 10 reports, and each of those reports have their own dedicated data set. Because if all those reports have share the same data set, then just publish one data set. That way you don't have to manage 10 different data sets, and then all the reports can point to this shared data set, right? So in this case, once you make that data set available, then now a report developer or a business analyst, data analyst can come here and say, all right, I'm going to create a new Power BI report off of that common data set or shared data set. So right here within Synapse, you see that now they have the same development experience that they had when you had when you opened Power BI Desktop. As you can see, if I switch over to Power BI Desktop, it's very similar development experience when I launch the Power BI report development within Synapse. And this is part of that holistic, unified, common experience that I talked about, where now users don't have to go to their desktop, launch Power BI Desktop, connect to a data set. They can just go to Synapse Studio, go to the Develop tab, and click select the data set, and launch a report development, a new report right from that same environment, right? This is that unified, holistic experience, all the way from data ingestion, data processing, ETL, to data modeling, creating some tables, some relationships, and then be able to make those data sets available in Power BI within that same environment, right? So this is taking a little bit of time. Let's see. So while that's loading, because the data set has to build its cache and probably hasn't done that. As a matter of fact, I know the issue why it's taking so long. One of the steps that we needed to do that I haven't done is once we deploy that data set was deployed temporarily using my credentials, right? But once that data set is deployed in the Power BI service, we need to provide that data set with a way to connect back to the source with perhaps a service principal or a proxy account that it will impersonate the user, right? So one of the steps I needed to do is I need to go to the Power BI service and change in the data set the credentials. So I'm going to go to settings, and under settings, you see that it is already telling us, hey, you need to provide the credentials to use to impersonate. So I want to click on edit credentials. And in this case, for now, I'm just going to use my OAuth 2 authentication, which essentially is going to use the credentials that I'm using to connect to Power BI. In this case, my user specified by the lab environment. So this is going to now use that a OAuth token that's going to use to connect to the data source and be able to refresh the data. This is only for refresh purposes, like or schedule refresh or on-demand refresh, right? So if I go back to my workspace and I try to schedule a refresh or click the refresh button, that is the credentials that it's going to use to be able to refresh the data set. Now, for when a user connects to that data set, it's going to look at the user's credentials and pass back the user's credentials to ensure that that user has is entitled to connect to that data source. So two different things, just to clarify that. Now that I have stored my credentials, I'm going to relaunch this. So again, I went to develop. I went to the Power BI workspace and click on Power BI datasets. If you refresh, you should see that dataset that I had published. So now I should be able to connect to that dataset. And there we go. So I forgot that extra step, but it's good so that you understand why it may not be working in your environment, right? You need to provide those that unattended account or service principal to connect. Now that I have that, the data set and be able to connect the data set and have my fields, I can create a very quick visualization. In this case, I can create a line and cluster chart. Can make that a little bit bigger. And in this case, we can choose profit as our line value right here. Salesperson key. So we can expand this a little bit here. Let me collapse this and expand my fields a little bit. So salesperson key, I'm going to put that in my shared access, and then my total excluding tax will go into my column column values. So now you can see, a quick visualization, quick way of analyzing your data. We can apply filters. So in this case, one of the filters in the exercise is from the filter section. I'm going to collapse this a little bit. We can say I want my profit, where my profit is greater than 50 million, I believe. Yeah. 1, 2, 3, 1, 2, 3, and then click apply filter. And now it filters our data to where my profit is greater than 50 million. And then if we wanted to, we can add slicers. So if you're familiar with SQL with Power BI, sorry, you have the concept of slicers. Oops, let me undo that. Not that slicer. And in the slicer, which is this visualization, make sure that that visualization is not selected, that you either drag it to an empty space or just don't have any visualization selected. If not, it will change that visualization to the new visualization that you chose. In this case, I just selected a slicer. And for example, if I wanted to, navigate this by, for example, my, let's see, package. Do I have a package description here? Right. So I have a different type of packages, right? And if you collapse this, you should get a little bit better And then you can say, I want package that are type packets. Each, there's no data for those, I guess, or bag, right? I guess all of those packages are each, not package themselves. But you get the idea. You can create filters, slicers that allow you to hone in on the data that you're looking for, create some interactivity, all of that within Azure Synapse. So that once that you have that, you can just simply save this report and give it a name if you want to create a new name. My report. Save. And then we can close. If we go back to our develop, develop. Where is it? Where did it go? Oh yeah, develop. Sorry. This is the pipeline that we have open. I'm going to talk about it a little bit. So we go back to develop and we go to the Power BI report section. You can see that my report that I created is stored there. So you can have some pre-built reports that users can just click there and access the report that will be pre-built. But if they have edit or contributor access, they can actually modify those reports or create a copy. They can just create a copy of that report and change the report as they see fit, or just create new reports using the shared data sets by clicking this icon here, Power BI report. If we navigate back to the Power BI workspace in PowerBI.com, we can see that report that we saved there is available in this workspace. So you can leverage things that users do in Synapse in other use cases where you want to give users access to the Power BI portal, or use this to get like a embed link to embed in your own application. And then the last thing I wanted to just come back to is this data pipeline. So this data pipeline was executed successfully. If you look at the execution, you will be able to see that it copied data from this store and then applied all the joins here and created a new table that is called the staging table. So we might need to just do a refresh, and we should see here that staging table that it created. Not sure if it created or not, but it should have created. Maybe I didn't run the debug session. Maybe I did. So now that we have the data flow up, we can click on debug, and we should see the progress here under the process, right? So now it's running that enriched customer data. Once it finishes, sorry, it should have been the other way around. Should be copy data first and then the data flow. So now we can debug that, and we should see that new pipeline version being queued and executed. And then it will generate the table under this SQL pool table. So with that, I just wanted to conclude the workshop now, with what we have covered so far. I want to thank you for joining us, and if you have any questions, please feel free to contact me. I think Madison or Nadia can put my contact information, but it's jose.chinchilla@agilesa.com. And I'll be happy to answer any questions. We're also going to be sending out a email to all attendees if you have any questions, follow-ups with a 30-minute time slot that, hey, you want to just chat about challenges or ways to implement Azure Synapse, I'll be happy to talk with you, understand some of your requirements, and provide some recommendations. And in general, any other particular question that you may have, I will be happy to talk with you about that. So we will be sending that contact information and the ability for you to schedule a 30-minute time slot with me for any question that you have. I'll be happy to jump on a quick call with you. We'll also be sending some other links from upcoming webinars, upcoming workshops, and other ways that to improve your skills, and more information about some of the services that we provide at AgileThought to implement Synapse in all the data analytics and AI services as well for our customers. So with that said, thank you very much, and I hope to talk to you and see you in some webinar soon. Thanks.